Hey everyone, I'm Daniel Skoog. I'm a senior mechanical engineering student at LETU University.
I'm Jared Heggeland. I'm a sophomore electrical engineering student at LETU University as well.
So right now,
Christian Polytechnic University.
So right now we are standing in this place called RGs Workshop. And what it is, all these freshmen here are getting to build their own 3D printer. Their first semester at LETU, they get to do this. And in addition to that, they learn solids modeling. And so right now, the freshmen are in the process of fine-tuning and building and completing their printers. And today we're going to give you a little demo of what a 3D printer does and how it works. Just kind of show you all what's up with it.
Yeah, so right now we've got this printer preheated for PLA. PLA is a type of plastic that you can print with. Super versatile, really easy to use. It's what we start with for all the freshmen here. And all we have to do is press this control button. We got to go down to print from card. And we're going to print kind of the staple first print at LETU, which is an articulated slug.
For this year anyways.
Yeah, for this year. The bed is preheating now to 70 degrees Celsius. So it's got to warm up so the print actually will stick to something, or else all of the plastic moves around. You just kind of get a jumbled mess. So yeah, now the whole printer is heated up. You can see it's starting to auto home. Pretty much what it's doing is it's just orienting itself as where the actual bed is, so we get a good print. You'll notice that this is the V8 of printers. This is the V7, this is the V6. That goes all the way back to version 1. This is the 8th iteration of printers that we've given freshmen.
So the plastic starts here on the spool, and then there's a motor right here with a beveled gear that is gripping this line of filament and pushing it into this tube, and this filament travels through this tube down into this end here. You can't really see it, but there's a hot nozzle. That's what we're talking about, is 220 degrees right now. That nozzle is hot, so as soon as that plastic hits that nozzle, it melts, and is because of the pressure created from this motor pushing the filament out, it's squeezed through that nozzle, and it's a 0.4 millimeter nozzle, and it's squeezed out and deposited onto the bed and onto other plastic that's been laid down, and it fuses to that. And that, in essence, is how 3D printing works. The flow of the files, it starts off as a solids modeling file, and whether that comes from SolidWorks or from some other CAD program, it doesn't matter. It just has to be exported as an STL file, which is just a file that's represented in 3 dimensions. It's made with a bunch of triangles, and so you take that STL file and you put that into a program called a slicer. And what the slicer does, it takes that STL and it converts the 3D part into a big line of what's called Gcode. And so what Gcode is, that's what the printer's reading. The file itself that the printer's reading right now is a Gcode file. And so on a Gcode file, you have it's basically a whole list of commands of the printer to follow. So it's like, go to this point and extrude this much plastic while you're moving there. And then go to this point, extrude this much plastic while you're doing that. And that times 100,000, that's one print.
And one of the really cool things about LETU is that's a lot of information, right? Going from SolidWorks to Slicer to actually getting a file on here to getting a physical print. But we learn all of that in Intro to Engineering Practice 1, first semester you're here. So it's kind of cool. You get hands-on experience with a lot of things right away at this university.
And I can speak from my own experience. After taking IP1, I knew how to 3D print. I knew how to design stuff in SolidWorks and create whatever I wanted from my 3D printer. And so the next class I had IP2, we're challenged to do just that. We have project goals, but no real guidance on how to meet those goals. And so we, the students, have to figure out the best solution. And that keeps on happening with other classes that I've taken. It's a lot of fun, and it's pretty exciting how vast the possibilities are with 3D printing.
If you look around, the lab we're in is called RGs Workshop. It's named after RG LETU. He's the founder of our school. We actually started off as a technical institute, so everything was about hands-on. Then we became a university and we added engineering, but that hands-on experience that LETU was founded on, that's stayed the same even today. I mean, I've had semesters where I've been in labs for 9 hours a week. You learn a lot of theory, but you also learn how to apply theory and put it in practice, which is really unique at a lot of engineering colleges are one or the other, but we're kind of a good balance between both.
Mm-hmm. And there's a lot of different fields you can go into that all have that hands-on mentality, whether that be civil or mechanical or bio, chemical. They're centered around just projects that really challenge the students to think outside the box and not just read a textbook and look, oh, there's the answer, but to actually combine their knowledge and to think critically on a problem and devise a solution and then actually build it, so then they understand what's going into a solution, a physical solution, and then so that later in the workforce they're better equipped to work in a team and to solve problems.